Firstly, we have to observe and note 30 trials of 6 rolls each. Next, we need to solve the question by calculating the probability of rolling an even number and an odd number using theoretical probability that we had learned. Let's moving on with the objective. The first objective to note the outcomes of the showing numbers on top of the die. Next, to find the experimental probability of rolling an even and odd number of a die. And lastly, to find the theoretical probability of rolling an even and odd number of a die. So, what is the methodology used in this experiment? The first step is take a die. Second, construct a table. Third, roll the die on an even surface. Fourth, note the outcome of the showing number on top in the table. And lastly, repeat the step for 30 times.
Next, we are going to construct a table. The table shows the result of 6-sided die being rolled about 30 times. From the result, we can see that there are the frequency for outcome number 1 with the frequency of 3, for outcome number 2 with the frequency of 4, then for the outcome number 3 with the frequency of 4, then for the outcome number 4 with the frequency of 5, next with the outcome number 5 with the frequency of 8, and lastly with the outcome number 6 with the frequency of 6. Next, we are going to construct a few questions. The first question is to find the experimental probability of rolling an even number. We use the equation of P equals to number of even number rolling over number of experimental trials. Thus, number of even number rolling based on the constructed table is equals to 4 plus 5 plus 6 over number of experimental trials, which is 30. Hence, the number of experimental probability of rolling an even number is equals to 1 over 2. Next, the second question is to determine the theoretical probability of rolling an even number. We use the equation of P equals to number of favorable outcomes over number of possible outcomes. Thus, the number of favorable outcomes based on the table is equals to 3 over 6. Hence, the answer of favorable outcomes is equals to 1 over 2. Next question is to find the experimental probability of rolling an odd number. We use the equation of P equals to number of odd number rolling over number of experimental trial. Thus, the number of odd number rolling based on the constructed table is equals to 3 plus 4 plus 8 over the number of experimental trial, which is 30. Hence, the number of experimental probability of rolling at an odd number is equals to 1 over 2.
So for the next question is we have to find the theoretical probability of rolling an odd number. So we use the equation of P equals to number of favorable outcomes divided with number of possible outcomes. So the number of favorable outcomes is 3 and divide with the number of possible outcomes, which is 6. So we get the final answer is 1 over 2. Moving on to the next question. What is the difference between experimental probability of rolling an even number and the theoretical probability of rolling an even number? Write an answer as a person rounded to the nearest whole percentage. So we use the equation of experimental probability of falling an even number minus with theoretical probability of falling an even number times 100%. So the experimental probability of falling an even number is 1/2 minus with the theoretical probability of falling an even number, which is 1/2 as well, and times with 100%. So we got the final answer is 0%. For the last question is, what is the difference between experimental probability of falling an odd number and the theoretical probability of falling an odd number? Write an answer as a percent rounded to the nearest whole percentage. So we use the equation of experimental probability of falling an odd number minus with theoretical probability of falling an odd number times 100%. And the experimental probability of falling an odd number is 1/2 minus with theoretical probability of falling an odd number, which is 1/2 as well, and times with 100%. So the final answer that we get is 0%.
I will explain the additional question for the experiment. The first question is, we roll 2 dice simultaneously. What is the probability of getting sum divisible by 6? I list all 6 favorable outcomes, which is 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, and 6, 6. I calculated with formula total number of favorable outcomes over total number of possible outcomes. The probability that I got is 1/6. The second question is, what is the probability of getting a total of at least 9? I list all the favorable outcomes for sum 9, sum 10, sum 11, and sum 12. For sum 9, the favorable outcomes is 3, 6, 4, 5, 5, 4, 6, 3. For sum 10, 4, 6, 5, 5, 6, 4. For sum 11, 5, 6, and 6, 5. For sum 12, 6, 6. And the probability that I got for total of at least 9 is 5/18. The third question, what is the probability of getting sum less than and equal 4? I list the favorable outcomes for sum 2, which is 1, 1. For sum 3, 1, 2, 2, 1. Lastly, for sum 4, 1, 3, 2, 2, 3, 1. I also use the same formula, which is total variable outcomes over total number of possible outcomes. The probability that I got for the probability getting sum less than and equal 4 is 1/6. For the last question, what is the probability of getting a doublet of odd numbers? I list all the variable outcomes of doublet of odd numbers, which is 1, 1, 3, 3, and 5, 5. I use the same formula, total variable of outcomes over total number of possible outcomes. And the probability that I got for doublet of odd numbers is 1/12.
For the conclusion, we can conclude that throughout the probability experiment, the odds of getting number of a random variable x varied from trial to trial. We can also know the difference between the experimental probability and theoretical probability of a random variable. Clearly, it is reasonable to state that probability plays an important role in the solution for statistical problems.